So group 17 में था कि you had trends in volatility. We discussed that. Okay, down the group, the melting and boiling points increase. They become less volatile. Why? Because they've got van der Waals forces, temporary dipole induced dipoles, which increase with size as the number of electrons they increase. Colors, they become darker as well. Okay, then you talk about bond strength. Bond strength, smaller atoms always usually have stronger bonds. Like इसके अंदर था कि when you have fluorine, the fluorine atom is so small that it's very hard to keep two fluorine atoms together because they have too many lone pairs and they're all repelling each other. So the bond that a fluorine atom makes is very, very weak. So this is what we discussed. And then we talked about hydrogen halides, HCl, HF, HI, HBr. This is not an issue. Why? Because there is no lone pair on the other side. So if you have an HF molecule, fluorine has lone pairs, but H doesn't have any lone pairs. So there's no repulsion factor over here. The smaller atoms, they always make stronger bonds. Or phir wo melting and boiling points, etc. HF has hydrogen bonds, while HCl, HBr, HI, they've got permanent dipoles and van der Waals forces, which increase down the group, which is why the HI molecule has a higher boiling point compared to HCl, but HF has hydrogen bonds. So that is one thing that we did. And then we talked about fluorine being the most electronegative. So it gains electrons very, very strongly. That becomes F-1. Iodine is a big atom, doesn't really like to gain electrons. So it has a lower tendency to gain electrons or get reduced. So the top one is a very good oxidizing agent. The bottom one is not a good oxidizing agent. But when it comes to the negative ions, it's a lot easy for I-1 to lose electrons. So bigger ions, they're more shielded, they lose electrons very, very easily. So Risha, ye clear hai ke down the group, it becomes easier to lose electrons. Is this clear?
Yes.
So the thing is that I-1 is a really good reducing agent. It gets oxidized very easily. So it's giving electrons to everyone. Whoever needs electrons, I-1 will give it electrons. F-1 would not do that. F-1 would hold on to its electrons very strongly. So Smita, you had these reactions. We did the first one. You had the NaCl reaction. So we talked about that Cl-1, it doesn't like to lose electrons. So it's a very bad reducing agent. So there is no redox reaction. So instead what happens is that when you add Cl-1 to an acid solution, the Cl-1 and the H+1 from the acid, they combine together to form HCl gas. So the acid provides the H+1 ions, the Cl-1 is present in the solution. So the two get attracted to form HCl gas, which is why you get a misty white fume when you add NaCl to concentrated sulfuric acid. So displacement reaction happens. Now, what happens down the group is that Br-1 and I-1, they really like to lose electrons. They're very good reducing agents. So when it comes to Br-1 and I-1, you usually get a redox reaction instead of a displacement reaction. So NaBr, you add H2SO4 to it, the Br-1 and H+1 would get together to form HBr. But the Br-1 would tend to lose electrons, give its electrons to sulfur, and sulfur is going to get reduced. So, and Br-1 would lose electrons to form bromine. I-1 does the same. I-1 is an even better reducing agent. So I-1 really likes to lose electrons. So I-1 loses electrons, gives its electrons to sulfur. So sulfur gets reduced to SO2S or H2S. And meanwhile, I-1 turns into I2. So yahan pe na, what's happening is that that our I-1 is really likes to lose electrons. And it eventually turns into I2. And the other one, H2SO4, is the one that is then forced to gain electrons and gets reduced. So it turns into SO2, it turns into H2S, or it turns into sulfur, it gets reduced to all these things. ठीक है, Anisha, is this clear?
Yes.
So it get reduced. So that's the thing that's happening. And one thing that you need to know about this is that Br-1 and I-1 are good reducing agents. But you need, if somebody is losing electrons, the other substance must be the one that would be gaining electrons as well. So the reaction, it's a two-way reaction. Redox reactions are always two-way. Like if one wants to lose electrons, the other should gain electrons. So you need a reducing agent as well as an oxidizing agent. So also remember that H2SO4, the reason H2SO4 gets reduced is because H2SO4 is a good oxidizing agent. ये point clear है?
Yes.
ठीक है, just like acid and bases, they exist together. You only have an acid that releases H+1 if there's someone on the other side that is gaining H+1. So redox reaction reduction can only happen if oxidation is happening. So if somebody is losing electrons, then there's somebody that would like to gain electrons. If there is no one who's gaining electrons, then that thing would not be able to lose electrons. So the reason this reaction, redox reaction, is able to happen is that H2SO4 is a pretty good oxidizing agent. So if you want to get only displacement, then change the acid. So Br-1 and I-1 will only give a displacement reaction, no redox reaction. Will only give a displacement reaction if with phosphoric acid. With H3PO4, they're going to give only a displacement reaction. And the reason for that is that H3PO4 is not a very good, it's not an oxidizing agent. So if I-1 and Br-1, they like to lose electrons, the other one is not gaining electrons, so they won't be able to lose electrons. So it's not an oxidizing agent. तो इसका लिख लेते हैं कि what will happen is कि you have let's say NaBr with H3PO4, the reaction would just be displacement. Like the H and the Br will get together to form HBr, and this has to be concentrated phosphoric acid. And what's left is going to be NaPO4 or Na3PO4. ठीक है, so is this clear कि these reactions,
Yes,
these reactions are very important. ठीक है, you have to remember these reactions. Cl-1, pretty much no redox reaction. Why? Because Cl-1 is at fault, doesn't like to lose electrons. Down the group, Br-1, I-1, they like to lose electrons, but you need someone who likes to gain electrons as well. So H2SO4 is a good oxidizing agent, which is why you get a lot of redox reaction. And if you don't want a redox reaction, just change sulfuric acid to phosphoric acid and you won't get a redox reaction. फिर ये कुछ disproportionate reaction है, which you have to remember that Cl2 with cold NaOH, it would produce NaCl and NaClO, which is sodium chlorate 1 plus H2O. So this is a disproportionation because Cl is getting reduced as well as oxidized at the same time. As a Cl2 with NaOH and hot NaOH at a high temperature, it would produce NaClO3. So again, Cl is getting reduced as well as oxidized. So it's a disproportionation reaction. So these equations are very important. They come very frequently. So with cold NaOH, remember what's going to happen with hot NaOH. The difference is with NaClO and NaClO3. The tricky part is balancing a redox equation. So you should know how this equation gets balanced. अच्छा फिर reactivity decreases down the group. So fluorine is very reactive. Chlorine is less reactive. Bromine, iodine, so even less reactive. So you got an explosive reaction with the hydrogen for fluorine. Iodine reaction that is, I mean, it doesn't even happen completely. It's an equilibrium reaction. As soon as HI is formed, it decomposes and forms H2 and I2 back again. So the HI bond is very weak. So thermal stability is that this bond over here is very weak bond. Bigger atoms have weaker bonds. The HF bond is very strong. Smaller atoms, they form stronger bonds, which is why it's more stable. Pirika testing, you have to remember if a solution contains Cl-1, it's the O-level test, you add silver ions, followed by aqueous ammonia. So Cl-1 gives a white precipitate, Br-1 gives a green precipitate, I-1 gives a yellow precipitate. What is this precipitate? This precipitate is that Ag+1 that you added reacts with Cl-1 to form AgCl solid, which is insoluble. Or if you add Ag+1 ions to Br-1, so they dissolve to form AgBr, which is also a solid, and so on. So this one is a solid, white precipitate. That's what you're getting. Cream for Br, I-1 is yellow. So Ag+1 with I-1 would give you a yellow precipitate. So, but ammonia ke saath, the first one would dissolve. AgCl dissolves in ammonia, dilute ammonia, or any type of ammonia. AgBr dissolves only in concentrated ammonia, whereas AgI is insoluble. So it's not soluble. Reactivity तो पहले discuss कर चुके हैं. More reactive displaces are less reactive. So remember, chlorine being more reactive than Br-1 will displace, it will turn into 2Cl-1 and Br2 would be formed. So more reactive displaces a less reactive. So if you have Cl2 plus Ki, the Cl2 is going to go and knock out the I, and KCl would be formed plus I2. Okay, is this clear?
Yes.
Just a second. So next is K. Uses of halogens, Cl2 kills bacteria in water, and so chlorine is a disinfectant. NaClO is a bleach, it also kills bacteria. CFCs are inert, volatile solvents, aerosols, etc. You've studied about CFCs, and they destroy the ozone as well. Okay, so CFCs, specifically, where did CFCs go? Just a second. So CFCs are chlorofluorocarbons and cause ozone depletion. So I'm going to write the equation of a CFC depleting the ozone. What happens is you've got a CFC. So in the upper atmosphere, you've got strong UV rays. So UV light in the upper atmosphere, it falls on the CFC and the bond breaks. And radicals are produced. And these radicals then go and attack the oxygen in the ozone. So they take away one of the oxygen and O2 molecules are produced, and in the next step, Cl radical is formed again, and two O2 molecules are produced again. So what is happening is that the ozone is constantly getting depleted. It's breaking down into oxygen. So ozone is this hazy smog-like substance which is present in the upper atmosphere that blocks harmful UV rays. So ये सारा बीच में Cl2 gas. But you should also add that there's bromine. There's a thing called bromine. Bromine compounds are frequently, they are frequently used. Are frequently used as fire retardants. One example is like so if we look at the formulas, brominated flame retardants. Okay, that's a better word. So these are organobromine compounds, organic bromine compounds that have inhibitory effect on combustion. So lots of just wanted to show you some of the molecules if there's any diagram for that. You can see the contents in plastics. So maybe if you can see an image. So here's one molecule. It's two benzenes and there's a bromine attached. So brominated organic compounds are often used as fire retardants. That's the main point. Okay, so bromine is often, so that's another use of halogens. Actually, we're going to move towards nitrogen and sulfur. So the first very basic thing is that 78% of the atmosphere is nitrogen, so that's obvious. N2 is inert, N triple bond is very strong. There are two very specific reasons why N2 is inert. One of the reasons is that it's got very high bond energy. So that's reason one, that the N triple bond N is really, really strong. And it's got high bond energy. A large amount of energy is needed to break this bond. And the second reason is that it's also inert because it's non-polar. So it's non-polar and doesn't attract other molecules. So there are two reasons, because there are other triple bonds that are strong as well, but they are very reactive. Like carbon monoxide, it's a very polar molecule. So this oxygen is slight negative, this carbon is slight positive. So you've got carbon monoxide, which is even stronger than, I think, the N triple bond N, but it's very reactive. Why? Because it's got polarity. And if it has polarity, it's going to react with other things. Then you have sulfur, which is present in, this is known as zinc blend. Okay, that's a very specific ore. And that's known as zinc blend. It's often present in a lot of fossil fuels, coal, such as coal and volcanoes. So there's a lot of sulfur, and most of the sulfur it burns when oxygen and produces sulfur dioxide, which causes acid rain. So how is acid rain formed? Again, this is O levels. Extreme temperatures in the car engines and lightning strikes. It heats up air. So air burns up. So यहाँ पे what's happening is that air burns up, catches fire. The nitrogen, which is supposedly very inert, it ends up reacting with the oxygen in the air, and they end up forming the oxides of nitrogen, nitrogen dioxide or nitrogen monoxide. This NO2 thing is a very good oxidizing agent, and SO2 is a reducing agent. So they both react together. the SO2 turns into SO3 because of the NO2 in the atmosphere. The NO2, where's the NO2 coming from? It's coming from the lightning strikes and the air heating up. Where's the sulfur oxides coming? They're coming from burning of fossil fuels and volcanoes. So the two react together and you get these reactions. The NO2 oxidizes the SO2. And then they mix with rainwater to form acids. So I'm going to write those equations over here. Okay, what's going to happen is that the NO2 is going to mix with water and it would form both nitric acid and it will also form nitrous acid. And the SO3 also mixes with water and ends up forming sulfuric acid. So your rain turns acidic when this happens. So they mix with rain. They mix with rain and both oxides, they turn into their respective acids. You can remember this is all O levels. So,
nitric acid and nitrous acid, right?
Sorry, both are nitric. It's one of them is nitrous. So they write two equations. There's another equation which is often seen, and that is that it's NO2 plus water plus I think half oxygen, and they turn it into nitric acid, or I think 2 molecules of nitric acid. So NO2 has two equations. So sometimes in the market scheme you see the first one, sometimes you see the second one. The NO2 reacting with water, so that would be 3 oxygens plus 1. Kitne chahiye actually? There's going to be 2 NO2. Just a second. So that makes 4, 5, and 6. So there are two equations. And acid rains, what do they do? Acid rain causes corrosion of limestone buildings, metal structures, the soil and water bodies, they become acidic, and skin and eye irritation. So all of this is happening because of acid rain. Here's my flue gas desulphurizations. Remember, what are flue gases? These are the industrial waste gases because most industries, they burn coal and raw fossil fuels like furnace oil. So it's got a lot of sulfur, and the sulfur burns up and produces sulfur dioxide. And because of the high temperatures in the fire in the furnaces, the nitrogen oxide, they also react to produce NO2. So same thing, just as acid rain. Now these gases from factories are neutralized by limestone or lime. So limestone or lime are bases. These are basic compounds. So when you react them with these gases, limestone is simply chalk. So the sulfur oxides, they're going to react to form sulfides or calcium salts. NO2 would form nitrates or calcium nitrate. Then you have the Haber process that you've studied in O levels. Most of the questions on the Haber process would be linked to the equilibrium chapter. So N2 reacting with H2 and producing NH3. So that was the Haber process. What was the source of nitrogen? Because you got it from air, because 78% of the air is liquid. I mean, 78% of the air is nitrogen. Where do you get hydrogen? You get hydrogen from cracking of oil. These are the conditions: 450, 200 atmospheres, and iron catalyst is used. A lot of questions on the Haber process are about equilibrium. So remember, equilibrium favors the products at low temperature. It's an exothermic reaction. So whenever you have an exothermic reaction, low temperatures are going to favor exothermic reactions. High pressures would favor the less gas mole sides. You can remember these were rules of equilibrium. And when you remove NH3, the equilibrium would try to do the opposite. It tries to produce more NH3. अच्छा, अब ये कि since it's an exothermic reaction, you're supposed to use low temperature. Since the forward side has less gas moles, so less gas mole side is favored at higher pressure. And if you keep on removing NH3, it's going to try to keep on making more NH3. So these are the preferable conditions that should be used for the reaction, but you can't use higher pressure, very high pressure, because economic cost would increase. You can't use a very low temperature because the speed of the reaction would be too slow. So 450 and 200 are considered to be the ideal pressure. Another thing about this reaction is this reaction has a very low yield, extremely low yield, or simply a very low yield. So that means there's a lot of backward reaction that happens. Not a lot of ammonia is produced. I mean, if you try to produce more ammonia, there's a lot of backward reaction happening. So at the end of the day, a very small amount of ammonia is produced. So it's got a very low yield. So unreacted reactants are constantly recycled. I said they are constantly recycled. Or that's it. I mean, this is all O-levels Haber process. You should know the uses. Okay, it's used mainly in the formation of fertilizers, formation of nitric acid, explosive detergents, dyes, etc. Here you had a contact process which was very similar. Okay, sulfur reacting with oxygen produced sulfur dioxide reacting to form sulfur trioxide, and sulfur trioxide reacting with concentrated sulfuric acid to form oleum, which is then diluted to form sulfuric acid. And again, most of the questions related to this would be related to equilibrium, how to favor the forward reaction, how to increase the yield. So it's an exothermic reaction, so low temperatures are used. The forward side has less gas moles, so high pressures are used. But again, higher pressure increases cost and lower temperature reduces the rate of reaction. So you don't really use a very high pressure or a very low temperature. And again, it's used in car batteries, paints, fertilizers are made from sulfuric acid. So that's pretty much it. Just a second, and let me also open the latest syllabus and have a look. Actually, Claire, Hania, is this, sorry, where is the, achha. Risha, is this clear? I'm going to share the link of this.
Yes, sir, it's clear.
Okay, most of the stuff just needs memorization. Okay, just hold on 1 second. Let me. Okay, just trying to see if there's something new. This is period 3. TK group 2. TK, we studied the oxidizing agents and the concentrated sulfuric acidic reactions. Cold and aqueous, anyways, we did that, did all of that. TK is kind of what we can do is we didn't do catalytic role. Just a second. So where did the catalytic converter go? Just a second. Somewhere there must be a catalytic converter. So there's actually, sorry, there's actually another page to this. Oh, मैं भूल गया था. अच्छा, so this one. Okay, अच्छा, these are just general stuff. Okay, how do nitrates end up in soil? Same thing. It's nitrogen oxygen heating up, reacting to form NO2, which ends up forming nitric acid, and that's where the nitrates in the form of acid rain, they end up in soils. So then you must know something about eutrophication, although it's an O-levels thing, but just general stuff that what happens, fertilizers, they get washed away into rivers and lakes. Most of your fertilizers are, what are fertilizers? That's one very important thing. So whenever you talk about fertilizers, so most of your fertilizers are basically NPK salts, and they must be soluble, because plants need to absorb them, so they must be soluble at all cost. So they're NPK salts, and which basically means anything that contains nitrates or ammonium or has N in it or P in it, phosphates or potassium in it. So any salt that contains, any formula that contains these three ions, that could potentially act as a fertilizer. So fertilizers are essential for plants need N, P, and K. So what happens is that rivers and lakes, algae grows and blocks sunlight and destroys marine plants because they don't get sunlight, and then bacteria feeds on the dead plants and consumes all the oxygen, which destroys the marine life, fish, etc. So acidic soils, if you have acidic soils, what do? You add lime and limestone to it. So the acid in the soil would react with the base. Both of these are basic. The other stuff is you should not add lime to soil that has been fertilized. Why? Because fertilizers are ammonium salts, and they react with bases to form salt, water, and ammonia. So this is about catalytic converter. Catalytic converter are that they're made up of honeycomb structure made up of palladium or platinum. And let me write the equation. So all these gases are produced. Carbon monoxide is produced due to incomplete combustion. This is produced when air burns up. The nitrogen in the air burns up. And you got this unburnt fuel as well. So what happens is that your unburnt fuel and your carbon monoxide and your NO2, they all react together in the presence of the platinum catalyst, which is the honeycomb structure. The carbon monoxide and the hydrocarbons, they turn into carbon dioxide and water. And the nitrogen turns back into, the NO2 turns back into nitrogen. So this is the equation that's written over here. और बाकी इनमें के NH3 is basic. Why? Because it's got lone pairs. So lone pairs, they attract H+1. So NH3 is very basic. Any N, whenever you see any molecule that has N in it and it has lone pairs, it will attract H+1. So NH3 is basic. And what else? Some extra points are that NO is colorless, whereas NO2 is a brown gas. And NO2 as an oxidizing agent plays an important role in the formation of ozone. Even at the lower atmosphere, it does that, which creates smog. Okay, the hazy substance in the cities ends up creating smog because of the ozone plus NO2 in the lower atmosphere is basically your smog. Okay, that's your smog. So yes, how the computer, all you have to do is you have to memorize this. Okay, let me share the board. And the other thing that has to be done is the other thing that has to be done is the first thing is memorization. So what we can do now is we can have past paper classes because we've covered most of the things, but we'll focus on organic and inorganic first. We'll do some past paper questions of these topics. Hopefully tomorrow we'll have a class on this, especially organic, so that we can revise everything that we've covered in organic so far. So we'll just do past paper questions mostly. The past paper questions related to inorganic, we'll probably do that a bit later after organic. But we're going to go through all the reactions. We have all the notes on these boards. So we're going to revise organic and do their questions first, okay? So चलो कल continue करते हैं, ठीक है?
Okay, sir. Thank you. Allah Hafiz.
Okay, take care. Allah Hafiz.